Let us practice for examination. We have 10 questions to find exact value of trigonometric ratios, including related acute angles and principal angle. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have many questions which are based on trigonometry, working with any angles. I'll call this as a test preparation since I have taken up related questions in this particular video, and I hope it will completely help you to understand the topic and get ready for the test. Let me first share with you the 10 questions which we are going to solve. First one here is based on related acute angles, and to find the exact value, we are given the angle of 240 degrees and we need to find the related acute angle and calculate exact value of primary trigonometric ratios. That means sine, cosine and tangent. You know, sine ratio is opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent, and you also know the cos rule. Now here is how you have to look at the angle 240 degrees. So 240 degrees is 60 more than 180. Do you see that? And therefore the acute angle is 60 degrees. Perfect. Acute angle is the angle which the principal arm makes with the horizontal, right? It is always positive and less than 90 degrees. So with that concept, I think we can move forward, correct? And this concept is extremely important to answer questions based on the topic, any angles, trigonometry. So I hope this question is clear. You can easily do it, right? I have answered some part of it. Next question here is similar to this, exactly similar. However, the angle is minus 210. So positive angles are measured in counterclockwise direction. Negative angles are measured in clockwise directions as shown here in orange. So 210 degrees minus means clockwise. And then it is how much more than 180? It is 30 more than 180, and therefore the related acute angle is 30 degrees. You get the idea. Since it is 30 degrees and you are in quadrant 2, right? So you are in quadrant 2. Now, when you are in a quadrant 2, you can find all these ratios with your triangle. And which triangle are you going to use? 30, 60, 90, correct? So, use the special triangle, 30, 60, 90, whose sides are 1, 2, square root 3. Makes sense, right? Here, the angle being 60 degrees. And that one is 30 degrees. So now you can answer all these questions. Absolutely clear, right? Perfect. The next question here is calculator based. Given theta as 200 degrees, calculate value of primary trigonometric ratios rounded to 3 significant figures. Now this is also a very important exercise, as you need to always calculate the angles, and normally you are expected to write 3 significant figures for the accuracy, right? You can visualize that 200 degrees is in quadrant 3, where only tangent ratio is going to be positive, sine and cosine will be negative, which you can check with the cos rule. Clear, right? Next question here is find exact value. Now you may have to rationalize denominator if required. Find exact value of primary trigonometric ratio from the given information. So now we are given principal angle 135 degrees, which lands up in quadrant 2. You need to find what is sine theta, what is cosine theta, what is tangent theta. Similarly here minus 120, right? Quadrant 3. What are these 3 primary trigonometric ratios? First find the related acute angle, then look into the special triangle which you make, right? In this particular case, the related acute angle is going to be what? 45 degrees, right? So that kind of a triangle whose sides are 1, 1, square root 2, right? Make sense? So that should help you to figure out. And you know the cost rule, right? So only sine is going to be positive. All others will be negative in this particular case. Right. Similarly, do for the next one. Now, many times we need to find the trigonometric ratios when you are given a coordinate point. So this type of question is, a point is on the terminal side of the angle theta in standard position. So in standard position means that the initial arm is along the x-axis. Do you see that? The initial arm is along the x-axis. And the terminal side of that angle is opening counterclockwise. Do you see that? Positive angle, counterclockwise. Perfect. Then the angle formed is called in standard position. And the vertex is at the origin, right? These are very important things to understand. So here you need to sketch and then write down the answers. So the question is, the point is on the terminal side of the angle theta in standard position. Sketch the angle. Find the exact value of primary trigonometric ratios of theta. For example, the very first one, which is 8 minus 6. It means what? 8 minus 6 means the y value is negative, x value is positive. That means you are somewhere here in quadrant 4, right? So the angle will be, that is going to be your angle, right? And with the cost rule, you know that this quadrant 4 means that only cosine will be positive and it's reciprocal, and the other trigonometric ratios are going to be negative. This point here is 8 minus 6. 8 is the x value, minus 6 being the y value. You get the idea, right? Now, when you have this triangle, it's very easy to find the trigonometric ratios. Similarly, you do with all others. Well, what is missing here? Well, if you make this triangle, hypotenuse is what is missing. So just find hypotenuse, you're able to give complete answers, write exact values. Clear. If required, you may have to rationalize denominator. This is a very important point. Since you do a square plus b square, you have here a radical, right? If this radical comes in the denominator, in that case, you need to rationalize it, right? If at all it comes, okay. Now here is a very simple question again for you, where we are given one trigonometric ratio, right? So it is, if cos theta is 2 by 5, determine all possible values of sine theta, tan theta, cosecant theta, and cotangent theta. So how will you do that? Well, a hint I can give you here, cos theta is given to you as 2 by 5. That means you make your angle, right? So 2 is the adjacent side and 5 is your hypotenuse, correct? So this is not to the scale for sure, right? So 2 and 5, right? And that's the angle theta. Once you make your triangle, now you can find this, which will be 5 square minus 2 square square root, correct? And then write down all the trigonometric ratios. Remember, you need to rationalize the denominator, right? 5 square is 25 and minus 4 will be 4. So you get 21 square root, right? So now you get 21 square root, which will be a part of your question. You might have to rationalize in one of the secondary trigonometric ratios, correct? Fine, I think this is clear, right? Anyway, in case you want to learn from me, you can always send an email on the address given. Even if you have doubts, you can send me an email, right? Okay, the next question here is, this we are done just now. Now, what we have here is that find exact value of all trigonometric ratios from the given information. Find possible values of theta. So we are given that cos theta is 2 by 5. Well, we just did it earlier. Anyway, the thing is, you have to give all possible values of theta. Now, that's kind of interesting, right? All possible values of theta. What does that mean? So, you may have to look into your previous solution. Now, when I give you this idea, as you know, cos theta is positive in which quadrants? In quadrant 1 and 4, right? So, in quadrant 1 and in quadrant 4, cos theta is positive. So, we're looking for these two triangles. And therefore, you have to give two set of values. One, positive values, all positive, for quadrant 1, and second set will include some negative values, right? Only cos and secant are positive in quadrant 4. Sine tangent will be negative. Perfect. Now you have to also find the angle theta. Obviously, there are two different solutions for angle theta. So that's a new part for you. Find possible values of theta. And same thing you have to do with sine of minus 1 over 3. Good? Perfect. Now let's look into the next example which we have. It says, sketch given angle. Find exact value of all trigonometric ratios from the given information. Find possible values of angle theta. Cos theta is 4 by 5. We are given that theta is between 90 degrees and 270 degrees. And it is positive, right? So that is one of your question. So do we have any solutions? Sometimes you may not have a solution, right? The second one here is sine theta is minus square root 3 over 2 and the angle is between minus 90 to plus 90. So if we have solution, find the value of theta. And then find all other trigonometric ratios, right? 6 of them now, right? Okay. Another question, similar type, is with secondary ratios this time. So we have cosecant theta as minus 2, which is between pi by 2 and 3 pi by 2. Now some of the students are working in degrees only. The others are doing both degrees and radians. So it is good time to practice both, correct? So cosecant theta, which is reciprocal of sine, is minus 2 and it is between pi by 2 and 3 pi by 2. You have to find the angle, right? Okay, so let's try to understand. So when I say between pi by 2 to 3 pi by 2, I really mean it is in this place, right? So quadrant 3 or in quadrant 2, right? These two quadrants. Cosecant is reciprocal of sine, right? Since it is reciprocal of sine, it has to be in quadrant 3. So you have to solve for quadrant 3 angle. You get the angle? Perfect. For cosecant theta. So that's a good hint for you. Try to do it. Now here is the last question of this exercise. The question here is, find exact value of primary trigonometric ratios from the given information. So we have minus 210 degrees. I have also worked out the related acute angle. Just make things simpler for you. Since we have come to the end, must be very tired by now, right? And here is angle of minus 135. We like you to find the exact primary trigonometric ratios from the given information. Correct. Okay. So how do you find this exercise, right? So I hope you like the set of questions here where we are giving you in details a lot of variety. Perfect. So for example, let's try to solve now. Okay. Find exact value of primary trigonometric ratios for the given information. So we are looking into minus 210 degrees. That means what? As shown, we have related acute angle of 30 degrees. So we look into our special triangle, which is 30, 60, 90, right? So I'm drawing the special triangle for you, sides being 1, 2, square root 3. The angle 30 degrees is right there. So if that is the case, and we know the cos rule, so we can say that cos is positive here, all sine and tan. So we're looking for sine of minus 210 degrees. How much is this equal to? Cos of minus 210 degrees. How much is this equal to? Tan of minus 210 degrees. How much is this equal to? Right? That is what we need. Since we are in quadrant 2, we know this value is positive and others are negative. You see how simple it is? That is how you should be working in all the questions which we have discussed so far. It makes things very simple. So from 30 degrees, if you see, opposite side is 1, hypotenuse is 2, and therefore sine value will be 1 over 2. The cosine value, adjacent value, is square root 3 and hypotenuse being 2. Tan is the ratio of opposite over adjacent, so it is 1 over square root 3. Now this value 1 over square root 3 should be rationalized, right? That means you're going to multiply and divide by square root 3. And that gives you the answer as minus square root 3 over 3. So your answer should be minus square root 3 over 3 and not 1 over square root 3. Otherwise, you're going to lose 0.5 marks, okay? Perfect. So similarly, you have to do the next one. So when you try to attempt this, you have to first make your triangle a special triangle, which is 45 degrees, right? Isosceles right triangle. And then you can solve this, right? So you go sides of 1 square root 2. The angle here being 45 degrees. Why I selected this triangle? Minus 135 gives me a related acute angle of 45 degrees, correct? So note here, related acute angle. (45 degrees). Since 135 is 180 minus 45. And therefore, now we can write down all our answers as sine of minus 135 degrees is equal to what? Cos of minus 135 degrees is equal to what? And tan of minus 135 degrees is equal to what? Correct? Since you are in quadrant 3, we know these values are negative, but tangent is positive. Got it? And tan value you can see is just 1, right? Okay. Cos and sine. Hypotenuse is given to us as square root 2. So it's a good idea to consider the other variation of this particular triangle where we'll divide each side by square root 2, right? Or multiply by square root 2. That's not a bad idea. So it'll be 2 square root 2. Square root 2. Makes sense. It is the same triangle with 45 degrees. But now the answers which I get have denominator of 2, right? So we could write sine theta as, let me write down using a different ink here, 2 over square root 2. Do you see that? So I don't have to rationalize 2 over square root 2. They are same for sine and cosine. Both are negative since you are in quadrant 3. So note, for quadrant 3, both sine and cosine are same when the angle is 45 degrees, correct? So do you see how easily we solve this particular question very efficiently? That is how you should be doing it. Okay. Now, let me take a few more examples which will help you to complete the exercise. We touched upon how do we find or solve the question when a coordinate point is given on the terminal arm. So we'll take up the first one, which is 8 minus 6 on the terminal arm, and we know we are in quadrant 4, right? So if I sketch this particular triangle, 8 is my x value and 6 is my y value, right? So it's kind of like this, where this is 8 and this is 6, right? So we may have to find this particular side. As you know, 8 square plus 6 square square root is what? 100, right? So you'll do 8 square plus 6 square square root, which is square root of 100, and that gives you a side of 10. And you remember the Pythagorean triple? 3, 4, 5. It is times 2, right? Perfect. The thing is, I made a triangle which is actually in quadrant 1. But, we know one thing, and that is very clear. It is that we need to keep cosine positive, rest negative, right? So we can write down here that sine of angle theta is equal to what? Cos of angle theta is equal to what? And tan of angle theta is equal to what, right? So, and the angle here, theta, when I'm talking about, is this angle, right? Full circle. up to this point, right? So let's say OA. Is that clear to you? Perfect. So let's say P, right? Because A I've used for all also, so P. Okay. So one exercise is find the angle theta. So you could find the angle theta using any one of these ratios, right? So sine theta, as you can see from here, is 6/10, right? It is important to simplify it to the lowest term. So your answer should be 3/4. You get the idea. Divide them by 2. Sorry, 3/5, right? So I wrote 6/10. I wrote 8. 6/10, 3/5. Now, cosine is 8/10. Dividing by 2, we get 4/5. And tangent is 6/8. Dividing by 2, we get 3/4. So those are the ratios. To find the inverse, you could use any one of these. For example, if you use tan theta, then theta is equal to what? So the angle theta will be equal to, you can sometimes write measurement of angle theta is tan inverse of 3/4, correct? Use calculator to find this particular value. So you can put the calculator in degree mode, right? So we are working in degrees at present. Shift tan inverse of 3 divided by 4, right? It gives you how much? 36.869. So we can write this as 36.869. So I'm rounding it to 9 degrees. You see that? So we found the angle also. We have sketched it. So that is how we'll solve each part, right? So follow this method to solve B and C. Let this be your practice test. Remember, in case you still have doubts, you can always contact me on the address given, right? So I hope you are getting the idea of how should we be solving such questions, right? 210 degrees, we did it earlier, right? So now, here also, the two questions we had done earlier. So with these examples, I think you got an idea of how do we solve such questions, correct? Perfect. Let's take sine theta equals to minus 1/3. So when I say sine theta is minus 1/3, in that case, we are in which quadrant? We are in either quadrant 3 or in 4, right? So we have to now solve for both the quadrants, quadrant 3 and for quadrant 4, correct? So it says find exact values of all trigonometric ratios for the given information. Find possible values of theta. So we get two possible values of theta, right? So you have sine theta equals to minus 1/3. Idea is you find the related acute angle alpha, which will be always positive, and that will be sine alpha will be 1/3. So alpha will be equal to sine inverse of 1/3. So let's figure this out, right? So we'll do shift sine inverse of 1 divided by 3. It is equal to 19.47. So alpha is equal to 19.471, right? So I'm rounding this to 19.5. So we got the related acute angle, but to work with, I'm going to work with at least 3 or 4 decimal places. You get the idea, right? So now we have this particular angle with us. What are the actual angles? You see, we can work with 19.47. How? Remember that in quadrant 3, tan is positive, right? And in quadrant 4, cos is positive. All and sine other quadrants we are not really interested in. So now you have to make 2 different columns, right? And write down the trigonometric ratios for quadrant 3 and for quadrant 4. You get the idea. And find all the trigonometric ratios. For example, sine is given to you. So what will be cosine? What will be the other ratios? You could do that, right? So best is sine theta is minus 1/3. So let's make a triangle for this, right? So I'm making the triangle here. theta, and we are given sides as 1 over 3. Perfect. So actually this part which we just now did was to find the possible values of theta. Now these values of theta will not be used to find the exact values. Now we are doing part this, find the exact values. To find exact values, always make right triangle. Do you understand? So the other side will be what? 3 square minus 1 square. That means square root 8, right? 9 minus 1, square root 8. Which you could also write 2 square root 2. You get the idea. So once you have this particular triangle, you can answer your questions. Perfect. Remember that in quadrant 3, tangent ratio will be positive, and quadrant 4, cosine ratio will be positive. Is that clear to you? Right? Sine is given to you, right? So when you write this, you write here cos of angle theta is equal to 2 square root 2 over 3, which is positive, and tan of theta in quadrant 4 will be 1 over 2 square root 2. You get the idea. This has to be rationalized. Multiplying by square root 2 will give me square root 2 in the numerator and 2 times 2, 4 in the denominator. But this value is going to be negative. You see that? We are working in quadrant 4. When you do the same calculation in quadrant 2, in that case, in quadrant 3, you write tan theta as equal to positive square root 2 over 4. You see that? But cos theta will be negative 2 square root 2 over 3. You get the idea. That is how you are going to answer. And you have to provide both sets of values related to the quadrants. Perfect. So I hope with this I have answered almost all the questions for you, leaving few for you to explore. You get the idea. So feel free to write your comments and share your views. If you like and subscribe to my videos, it will be great. You can always contact me on the given address. Thanks for your time and all the best.